All right. I think we only one part left in uh, of the topic in chapter 8. Okay, and the last parts uh, usually is under the subjects of VIF, and VIF means variance inflation factors. Variance inflation factors. I'll show some of the uh, material here. Okay, and okay. Although looks complicated, okay, but uh, I think it's okay. I'm turn this on. Okay, is it on, right? Just a few minutes. Let me just take in two variables as an example first to show the formulas, okay? To show the formulas, if I use two variables, and it can be more easier to understand it from the basic, okay? And thinking about the model, is it, can you see that clearly? Or maybe I turn it, will it be too dark for all of you? It's too dark? It's okay, okay. Maybe this is better, right? Okay. If you look at the model like the first one, equation, okay, y, and I have two x variables, okay, x1 and x2, and usually we don't see the formulas, right? But actually, if we have the output, this is the formulas using OLS to get the numbers, as long as you have the y and x variables. The observations, data, I mean the data. Okay, then this is the beta 1 and this is the beta 2. And looks complicated, okay? But never mind. Don't worry about it, okay? And this is called coefficient. And what is the next column of the coefficient from the output? The next column is standard error, right? Remember that? So look at this one. Look at this one. Look at these formulas. If I have two variables, okay, the standard error, actually, this is the variance, right? Is the square root of this. Okay, this is variance. Standard deviation is the square root of the variance. Okay, look at the formulas like this one. And if I express this one as this one, so what is the VIF? Is what we call 1 over 1 minus R12 square. What is R12? R12 is the coefficient of correlation between x1 and x2. Okay? Okay? So this one is the coefficient of x1 and x2. So since we are in the topic of multicollinearity, what do you think if x1 and x2 are highly correlated? The coefficient of the correlation is pretty high. What's the range of correlation coefficient? -1 to +1, right? So if you square it, if they're highly correlated, after you square it, and the number will be high too. For example, if the correlation coefficient is 0.9, means 90%, 0.9, then square it will be 0.81. So it's 80%, something like this one. So after using 1 minus this one, okay, so for example, I'm using 0.9 as a coefficient, correlation coefficient. So R square of it will be 0.81. And 1 minus 0.81 is what? It's something 0.2 left out. So 1 over 0.2 turn out to be 5. Okay? So we're saying that VIF, let me show. Okay, let me still leave it here. If I have just only 2 variables, the VIF turn out to be 1 over this parts, right? Okay, all right. So in other words, the correlation of some particular number with the rest of the x variables. This example just only x1 and x2. So the rest of the variables of the x1 will be x1 and x2, the correlation coefficient. But if I have the model which I has k variables, okay? So this parts turn out to be this. So I'm using the capital R squared instead of original small r. This is small r, means I'm using that just for 2 variables. But this is the one with k variables. Understand what I'm saying? So this one is turned out to be what? If I have, for example, 1, 2, 3. Okay? So this is, if I say R1 squared, is turned out to be using x1 as in y, and the rest of the x, means x2 and x3, as an x, and run it. The correlation turned out to be what? What do we say? This coefficient of determination. It's R squared, right? So this is what I'm using R squared here. So R1 squared means what? Means using x1 as a y variable, the rest of the x as an x variable. So if I have 3 variables, means I have this one, R1 squared, R2 squared, R3 squared. Okay? So each one of, and this is K2, so means each one of the variable I can calculate its own VIF. Okay? So the higher correlation of one particular variable, x variables, with the rest of the x variables included in the model, then the VIF is high. Okay? This is what we are saying, that if one variable has highly correlated with the rest of the x variables, then this model suffers from multicollinearity by using VIF criteria. Okay? Understand what I'm saying here? All right. So this is the last part to for this chapters to detect multicollinearity. So would you like to use the example, okay, which we just used it last week, CONS8. In that case, I have just only two variables, okay? Then using the e-views, okay, so you all have that data with you? Do you have all the data, CONS8 with you? You should have it, right? Can I open it? Can I turn it? Oh, yeah. This one, this is 8. We use e-views and the CONS8, which we did last week. Okay? All right? So first of all, let's run the regression just before, okay? So I'm using y variables, yd and la, as an x variables, and run the regression. And this is the output we saw last week, right? Am I right? You all have that with me? Yes, right? Okay. With this output, okay, I can run VIF. Then where is it? Let's see. You need to run the VIF from the output. Okay, look at view. Did you see the first on the left-hand side, upper left-hand side, the first function called view. Then look at let me see. Where is it? Okay, sorry. Okay, this one. Oh, yes, coefficient diagnostic. Choose the coefficient diagnostic, the first one, and the last, this one, okay? Then choose the variance inflation factors. You see that? Then look at the number in the last columns called centered VIF. This is the VIF. Okay, let me show the VIF here. Since we say VIF is equal to 1 over 1 minus r squared, this is k. This is k, although we just have 2 in this example, right? So I'm going to say that r squared k. If I have, this one should be between 0 and 1. Okay, so let me start it from the smallest. Okay, although there's something, even smaller than this one. But I just want to show the relationship, okay? 0.2, 0.3, 0.4, 5. (0.9). Okay, then what's the VIF? If this is, then it's 1 over 0.1. Therefore, it's 0.9. 1 over 0.9, so which is 1.11, right? Okay, then this, for example, if this is 0.2, 0.5, so means 2, right? And this one, 0.8 is 5. And this one is 10. So you know that the higher the r squared, then the bigger of the VIF. So in other words, what is our VIF? 36. So you know that, which is something even higher than this one. And then we say that if I have k variables, I should have k VIF. And individual x variables should have its own individual VIF to show the relationship of that particular variables with the rest of x variables. what is this VIF here from if I have two variables? Didn't you see the same VIF? Why? Why you have the same VIF? Okay, if I calculate the VIF YD, I'm using YD as a Y variable, then LA as an X variable. Then see the correlation and square it, right? Okay, then if I'm using LA as a Y, and again using YD as an X. So even I have the different Y variables, just reverse. So therefore their VIF is exactly the same. It means that if you just have two variables, you just have one VIF for both. But if you have more than two, I think that's different, right? If you have three, you should have three different VIF. Okay, understand what I'm saying here? Okay, so this is what you see. Only have one VIF with two variables. The same VIF, I don't mean one VIF, the same VIF for both variables. Okay, so okay, and I like to say that there's some special name for this one, okay? To calculate this one. This one is using some X variables, which is K, as in Y variables, then the rest of X, okay, as an X. Okay, and usually we call this auxiliary regression. AUXILLARY. Auxiliary means assistant. Auxiliary regression. So if you see something, some names as auxiliary regression, it can be many different expression. I mean, the model is different, but usually when we say auxiliary regression is something related to regression, which is then the real model we want to empirical model. Okay, it's not the empirical model we want to use, but some regressions which will help this empirical model which we want to use. Okay, we'll get to these terms, many times in the future, even in the time series data. Okay, all right. So we know that. How do we detect the multicollinearity? We have learned that last week. What are they? How do you detect? Means the model is significant, but individual coefficient of the variable, X variable, is not significant. Okay, this is the first detections. The second one is pairwise comparisons, pairwise coefficient correlation. Okay, the third one is partial correlations. Okay, which I cannot use it directly from eViews, and I need to use the formula to do that. But I know that you can use the Python to do it. Okay, all right. The third one is what I say. This related to VIF. The fourth one, somebody will just run auxiliary regression. Since I have run this one, then I know the VIF. If this is higher, the VIF is higher. Okay, so this is the fourth one, and VIF will be this fifth one. So there's 5 criteria, and somebody used another term called tolerance. TOLK. What does that mean? Actually, this is 1 over VIF. Okay. So the higher this one, the smaller of this one. The higher variance of inflation factors, the less the tolerance. Okay? So you will see some maybe the articles, they show VIF, or sometimes they show tolerance, or they say something auxiliary regression. I think these three are really close. It's some this kind of relationship. Okay? All right, and then this is the last topic of detection. Okay, how do you detect the multicollinearity? Then the final one will be what? What's the remedy? Okay, I think the remedies for multicollinearity, if you look at books, what's the author recommend? What's our author recommend? Did you see that on the 8.4 parts of the remedies? The author says, do nothing. Do nothing. How wonderful. If I find out problems, then I don't have to do anything. Then why should I find it out? Okay? The author said do nothing means it doesn't mean, it really doesn't care whether you have the multicollinearity or not. Okay? It means that multicollinearity, if you are not really known about the relationship of some certain x variables, then if you run the data and you see some suspect variables for multicollinearity, then usually it is the problem of data set. So multicollinearity problem can be said that it is the problem of data set. If you can have another data set, maybe the multicollinearity problem disappeared. Okay? So if it is possible to get another data set, then try another data set. That's the best way. Okay? Then usually, especially for your thesis, right? Your dissertations, usually I don't have another data set. If I really have data set, then why should I run all this data set only? So usually we don't have it. So in that case, what do we do? Just drop the one which is really make sure it is redundant. Okay, but when we do this regression analysis, always remember the sequence. We start with what? Literature review. Using literature review to choose your X variable. So if the literature or the other research thinks this variable is very important, then do not drop it out. Even they do have multicollinearity problem. Do not drop it out. Okay? Drop it out only, it's just related variable. All right? And in our textbook, we do have some examples, but I think I would like all of you to read it by yourself. I think you don't have any problems with it. Okay? And so I'm through with chapter 8. And I'm going to give you the assignments, which is due next week. Okay? And let me show you the the detail of the assignments, okay? Let me get out of here. No. Yes. No. All right. Okay, this is the assignments which are already in the iLearning systems. Do you know how to get, can you go to the iLearning to see the assignments I just posted it? Can you see that? Yeah, which is, you can do it at home first, then come to the class and turn it in. Or, the turn time, I put it 9 o'clock. So you also can do it at home before you come to the class, okay? And I put the, I leave it as 2 hours, means I want to always change the time, all right? And let me, you all see that? Let me see that. Yeah, but you can see the assignment, do assignments, right? Then from 9 o'clock to 11, right? So this is the assignments. So far you cannot see it, okay? But I'll show you. Excuse me, can you get it from, this is the only way you can get it? But did I put it in an email? I think I didn't do it, right? Did I do it? Oh, you did. But did I do it? Did I send it in the email? I have a little I think I forgot it. But you did, right? Okay, good. This is the assignments. I sent it to you. And this is the data. I give it to you the first time we met, right? Okay, so this is the assignments we want to use for the data set we need to use for the assignments, okay? And those are the definitions of variable. Okay, remember that you're going to use 15 x variables. And the y variable is hours. Okay? Okay, then my question here. Okay, look at this. First of all, look at this question is whether you understand or not. Is that clear for all of you? So actually you have to do it from number 3 step, okay? Run the regression model and check the expected sign. I already put expected sign on the variable list. Did you see that? This is the sign for the expectation from literature. Okay, so I already put it. So run the data and check the signs and tell me the significance of regressor. What does the regressor mean? Just x variables. X variables also named regressor. Okay, there are several names for x variables called explanatory variables and regressor. I think these two are the common terms. Okay, or independent variables. 3. Okay, 3 terms for x variable: independent variables, explanatory variables, or regressor. And what are your findings? So show me. When you run the regression models, you need to show me the output. Okay? Then under the output, say something about my ask. Okay? All right. The fourth one is detect whether multicollinearity problem exists. Then the first one, I'm asking to using pairwise correlation. Since the first one, significance of regressors, is already in the third step. Okay, so I started with pairwise correlation among the x variables, explanatory variables. Then B part's optional, which is run and explain partial correlation coefficient. I know that, you're not able to do it from the e-views, and it's so hard for all of you to do the Excel. So if you all like it, show from the Pythons, okay? And you don't have to do that if you don't know how to do the Python. Okay, so this is what I'm saying, optional. Okay, and C parts, run and explain yes. No, this is correlation. It's not covariance matrix. You have to find look at this is not. You have to look at view. Then using open X variable as a group. Then as a group, open it. Okay, then view. And look at this covariance analysis. Okay, then click correlations. And click this out. This is the one. Okay? All right? This is pairwise. This is not. This is pairwise. This is not partial. This is just pairwise. Okay? And C, run and explain auxiliary regression. This is what I'm saying here. Remember I have 15 variables. So you should have 15. So this is big work. And determine which explanatory variables are highly correlated with the rest of the explanatory variable. Okay, let me also say something about it, okay? How high is the correlation coefficient? No, pairwise. In terms of pairwise, how high is correlation coefficient? Huh? No, usually. Do you have this concept before? No. Okay, in business world, okay, if we run the correlation coefficient, usually is the one is higher, bigger than 0.7. 0.7. If it turns out to be suspect variables, okay, but not very that rigid. It's just a rule of thumb, okay. So you can think in 0.7 as something you should be pay attention to. Nothing is really fixed, okay? Especially in graduate school, right? All the solutions, there's not only one way, there's always a better way, okay? Then, thinking about using correlation coefficient as a 0.7 as a criteria, okay? And, if you use 0.7, then square will turn out to be pretty close to 0.5, which means VIF is 2. Okay? Then, especially in business world or is in education, they do some analysis in education and in business. Okay? The VIF we'll really pay attention to is bigger than 5. But again, this is just as a rule of thumb. And so if VIF bigger than 5 means what? Means R squared is already 0.8. Okay? So after you run of the data and the auxiliary regression, determine which variable is highly correlated. Okay? Then D, check and explain the variance inflation factor of the regressors respectively. So you should have 15 VIF. So C is 15 auxiliary regression. This is 15 VIF. Okay, then number 5, suggest a remedy to deal with this multicollinearity problem. Do not answer, do nothing. Okay, do something. Okay, just give one remedies, which you think you can solve the problem. Okay. Well, I don't care. I really, if after the class you need to do some discussions, feel free to do it. Okay, all right. And suggest a remedy to deal with. Yeah, this is the first question. Any questions about this one? Yes. Since I already give you the data set, you're unable to increase the sample size, right? Okay. Well, so in other case, you may try to drop some if thinks it is redundant.
I mean, like, what is the best ways to do nothing?
Well, in this case, the best way to do nothing, it doesn't work here. I'll rerun it. Okay, so since you already say something, so this one will be drop the redundant variables. Okay, try to drop, but give me the rationale about doing that. Okay, why do you want to drop this one? Okay, we have some criteria to tell us to drop some kind of variables, right? Okay, this is the first one. Any questions about this? Okay, there's another one, okay, which is, just give you some ideas about the if we do have multicollinearity problems. Okay, look at this, set 1 and set 2. Okay, we have x1 and x2, two variables only. Okay, and from the eyesight, do you think x1 and x2 have some correlations? Now this two set, x1 is the y, x1 are the same. The only difference is, let me see. I wanted to change from this two. Otherwise, exactly the same, right? Okay, I need to change this one. So I'll send it again. Sorry about this one. I have to change it. This is, we wanted to know that if in some situations, maybe we made a mistake to mix one variables, which is x2, on the different numbers. So for example, set 1 is 4 is 10, 6 is 0, and it turned out to be 4 is 0, 6 is 10, right? This is the only difference for data. Isn't this a very small difference of the data set observations, right? And I like to, the only difference between two tables is, I think this is two sets, is that the third and fourth values of x2, third and fourth value of 2 are interchanged. Okay? Regress y on x1, x2 in both sets, obtaining the usual OLS output Then B, what difference do you observe in the two regressions, and what accounts for this difference? Okay? Try this one. Okay. So first of all, I need to see what's the difference between these two, right? Okay, then answer the questions related to the problems. Okay, and this one, I just say that after you know, all in Word file, okay? Write down everything in the Word file. And do you know how to put the output from eViews into the Word file? Okay, I'll show you how to do it. They all know how to do it, okay? Let me see. Where is my I have to run it again. So okay, we have this. This is my eViews output, right? Then highlight everything, then hit right. Then make a copy, then format it. Okay, then I use the Word file. Let me just choose one. Using. No. How to get this one? I wanted to. I wanted to have the beginning one. Hey, where can I get this one? If I wanted to no. I want exactly a new Word file. How do I get it? How do I get a new one? No. Send this one. 新增啊. Okay, here. This one. Okay. After I have copied, then I just paste it. Then you have all this output using the way I did. So you may try it now. Okay, use the output, then copy it, then paste it into the Word file. I like to say something about this one. After you have this output, did you see that they have the date and have time? You know, before the date and time will show me that whether you run it by yourself or not. Okay? So do not copy somebody else. I believe you don't do that. Yes. Huh? Yung screen. Oh, yes. It is okay too. If you. Oh, really? Well, I hope everybody will not do that and will be innocent or be ignorant of doing that. But you know, this is just for your own benefit. Okay? You mean if you use that way, you can also change the date and change the time by yourself after you pasted it, after you have it.
No, after paste it this way.
You mean I have done this one, then I can change the time here? I can change the time from 58:06. Oh yeah. Yeah. So there's no way to detect, right? But I hope everybody don't do that. Okay? All right. All right. All right. I'm not smarter than students for doing this kind of things. Okay. Okay. Do you usually nowadays did you try Chat GPT? The GPT work these problems for you? Cannot do that. Oh, how good. How wonderful. Can you run this? Oh, they can make formulas for this one? Oh, but you have to do it by yourself to calculate the VIF after you have the formulas. Well, you still have to a lot of work, right? It's better to study and know how to run these eViews or Pythons. It is more convenient. All right. I like to learn ChatGPT too. See whether they can help me to count my students' grades. All right. All right. So so this is about assignments, which will be turning next week. Okay, is that okay? This one, assignments. Okay, so in the future, my assignment is something like this one, okay? Then after you turn in, so next week, I will spare some time, ask you to do the presentation after you turn in it. So you have to do the presentation too. Tell me that, what you have done. Okay, explain it to me, all right? Okay, so there's no problem with this one, right? Okay, so I'm through with chapter 8. And then today I'm going to cover chapter 10 first. Okay, yes. Huh? Excuse me? Any questions? Well, chapter 9 is time series. Then after chapter 10, okay, although the topic about chapter 10 can be a little bit related to time series, but most of the situation, the topic in chapter 10 occurs in the cross-sectional data. Okay, so I will talk about that one first. Then after that, the rest of the semester are all time series. Okay, all right, that'll be more clear cut. Okay, so I'll cover chapter 10 later on. All right, okay, then let's have a break. Yes, yes. Mm-hmm.
So we're going to try all the combinations of the
Yeah.
Oh, so
No. I have 15 x variables, right? So you should run 15 auxiliary regression with each one of them as a y, and the rest of the x as an x. Understand what I'm saying there? So if you put x1 as a y, then x2 to x15 will be the x. If you run the x10, then the rest of 1 to 9, then 11 to 15 as an x variable. Understand what I'm saying here? So this one is more tedious. You have to run 15. And these numbers, after you have this one, of course, you will have this R square. Okay? And these numbers will match with the VIF you get it from eViews. Factorial? What do you mean by factorial? No. What do you mean by order?
Like if you try to first the 15, one each.
Yeah,
the
x1, x2, x2, 3.
So one regression would not have 1, 2, 2, 4, 3, 2 combination of the regression.
No. Since we have x2 and x3, it really doesn't, huh? No. I said again, okay? Using individual x as a y variable, the rest of the x's as an x variable. Understand what I'm saying? So, right. So, there's no combinations at all. We don't have to do the combination. Actually, the auxiliary regression is wanted to know this particular x variables, the relationship of this particular x variables with the rest of the x variables. Okay? All right. Okay, let's have a break. And by the way, I like to use this guess. Go to the chapter 10. I want to use guess 10 as an example for chapter 10. Okay, download this. We'll have that data set. I already put it in Ilonis. Okay, download it from there. Before I doing this one, I need to explain the concept first. So I may use this data set today. I hope I can use it. Okay, then this is heteroscedasticity.